Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is running stateful applications on OpenShift need a cloud-native storage stack. Our speakers today are Tushar Doshi, who is Technical Director, and Madhura Gaonekar, who's Principal Engineer at Robin. Welcome to both of you, and thank you so much for joining me today. But before we get started with the presentation, I want to hand things over to Michael Waite, who is with Red Hat, and he's just going to say a couple opening remarks. Go ahead, Michael.
Hey, thanks, Charlene. Yeah, I just wanted to say hello, everyone, for joining the webinar today. You know, I'm responsible for our partners here at Red Hat, or specifically our software partners. And you know, when you have a company like Robin.io, they've certified their software for Red Hat OpenShift, and they have an operator, and it's available in the Red Hat marketplace. So if anyone wants to go check it out, it's just marketplace.redhat.com. But we do these webinars with our partners because we want to help drive market visibility for their applications running on OpenShift. And so with that said, over to you, Tushar.
Hey, thanks, Michael. So welcome to the webinar. So today in the webinar, we will talk about why the cloud native storage is needed on OpenShift. What should be the typical characteristic for an ideal cloud native storage would look like? What do we expect cloud native storage should give to the application? What do applications really need from the storage stack? And then we will go over what are the DevOps workflows which you can do when you have this storage stack. And then we will have a small demo, and then we can have a question and answers at the end. So these are some of the CNCF survey results, and these essentially tie up with some of the CNS storage stack requirements. So if you look at them, you see that there are like 6.5 million cloud native developers. I think it's a fastest growing developer community over time across any other project. And then you see that 84% of the responders said they have containers in production and mostly on Kubernetes. And there are 14% who actually are using stateful applications in production on Kubernetes. So with these two things in mind, you have 6.5 million developers. You don't, I don't expect that everybody would be a storage expert. So what you need is a very simple storage stack, which anybody can understand, and should be very easy to use, and it should be production ready, since people are ready to deploy their applications on stateful applications on Kubernetes. And if you see at the last two statistics, there are like 65% who are using Helm for deployment, and 50%, more than 50% are using it in multiple clouds or hybrid clouds. So with that, you should have application as your center of focus, and all the DevOps workflow should be tied around those applications. And then with the multiple cloud in picture, your CNS stack should be able to deploy across any clouds transparently without worrying about the underlying infrastructure, and it should abstract all these complexities from the applications or the developers. And if you look at the right side, the chart says that why people are going for these cloud native technologies, right? Be it Kubernetes or Prometheus and so on. The deployment time reduction, the scalability, availability, cloud portability, and so on, right? So for stateless application, Kubernetes is providing all these features beautifully. But for stateful applications, now Kubernetes has to integrate with somebody else, and which becomes a cloud native storage stack. So that stack should ensure that all these highlights and the benefits which are provided by Kubernetes are still valid when you are deploying stateful application on Kubernetes. Now let's go to the next slide. So what are these cloud native applications? What are the typical characteristics that are important in this Kubernetes ecosystem? So if you see that it should be independent of underlying infrastructure. For a minute, let's only talk about stateless applications, which don't need any storage. So what they require from the underlying infrastructure is CPU, memory, and network, right? So if your pod goes down or if your host goes down, they will just start on other node and they don't have any state to carry along with them. So that works perfectly well. They are highly elastic. That means they can be scaled up very fast, they can be scaled down very fast, and it should be in matter of seconds. And they are resilient to failures. As I said, if the pod goes down or host goes down, they will automatically fail. Now let's go back and talk about them. Talk about stateful applications in the same scenario. So these cloud native applications also need storage. So now cloud native applications also include databases, message queues, and your big data applications. So it becomes important that they would have similar characteristics as their stateless counterparts. So when you say it should be independent of underlying infrastructure, now these applications require some kind of characteristic. They require a media, say it could be hard disk, it could be SSD, it could be NVMe. The storage could be locally attached, it could be remotely attached, or they could be running on-premises or cloud. And the characteristic of storage across these two are different, right? So your storage stack should abstract all these complexity and give what application needs, and which would, in most of the cases, is the best performance without losing any availability. And it should be highly elastic. So it should go up and down. That means your storage stack should be capable of giving out volumes or removing volumes, and there could be more. There would be a lot of containers or a lot of requests for creating volumes, deleting volumes. Your storage stack should handle it. But as their stateless counterparts, that's not enough. So here it might so happen that as your pod is writing the data on your volume, the volume might become full. So you should be able to transparently also grow the volume or provide a capability to growing this volume. Or if you are underlying, say you are using EBS disk, it's almost becoming full. Your storage stack should automatically call your EC2 AWS APIs and should be able to grow the disk capacity so your application does not incur any downtime. And it should be resilient to failure. So we had pod going down, host going down, but with the stateful applications, you should also worry about disk going down or disk failing and all those kind of storage situation, or the disk not being accessible, right? So if say your pod is running on node 1 and your storage is coming from node 2, so even if the node 2 goes down, node 1 will have downtime. So those kind of scenarios is something that storage stack should take care of. So being said, as I said, the Kubernetes is very beautifully built. When you are talking about stateless applications, where you need scaling or you need self-healing, upgrade, patching, and so on. But when it comes to stateful applications, there are still problems that needs to be solved. As we said, that data should always be available, no matter if a pod fails, disk fail, or the server fails. The next point is now with the changing ecosystem, the DevOps team is responsible for managing these Kubernetes clusters. Now the DevOps team knows their Kubernetes deployment very well. They know their applications very well, but that's where their knowledge ends, right? And storage is a very deep domain, and you need experts to manage that. Now you don't want every member of your team to be storage expert. So with that in mind, you need a storage stack which is being self-managed and gives out interfaces which are very easy for application developer to consume. Now the third point is about the app performance. You want a predictable app performance for your applications. So say your Cassandra is running in your data center. On day 1, it is getting say X transactions per second. And day two, what happened is somebody provisioned a new volume, and it somehow landed up on the same disk where the Cassandra volume was running. So now what you will see is degradation in Cassandra performance. So that's the noisy neighbor problem. So your storage stack should give way to have a predictable app performance. And then there comes a stateful application. There is data, and the data has gravity. And now and then it needs protection, it needs compliance, it needs security. All of these things needs to be taken care of your storage stack, and it should provide easy workflows for backing up the data or recovering from a user mistake or a system failures and so on. And considering what we talked about the second, that your DevOps team may not be storage experts. So that essentially means that they need some kind of a monitoring where they should know that how your storage stack is performing. If there is a disk is about to fail, depending on its characteristics, it should be able to get alerts and actionable input, which DevOps team can work on. So those are some of the things which are required when you are deploying stateful applications on Kubernetes. So let's talk about then what should that ideal CNS stack should look like. First and foremost, that data should always be available, right? So whether it's a disk, node, or a rack failure, application should always have access to the data, and all the replication or making copies should be left to the storage stack. One typical example for that is, as I mentioned here, is the disk movement in cloud. Say you have a EBS disk attached to a node 1. Now, if your node fails, so now since cloud storage essentially is like a SAN where this EBS disk can be attached to a different Kubernetes node and data could still be made accessible. So in that case, your storage stack should transparently move the disk around so that your application doesn't face any downtime. And it should have a rapid recovery. So in case of stateful sets, when the node goes down, what happens is Kubernetes takes quite a long time before it can start another stateful set pod. So your storage stack should be intelligent enough, since it has a knowledge of node going down, it should be able to move the pods and bring up alternate pods at the right location, or at least should help in rapid recovery. And it should be application centric, right? So as we discussed, that what is important is application getting right amount of storage with right set of requirements. So your storage should talk the application language and not the underlying storage language. So say my application. So we were talking to this CDN vendor, and what they were saying is we want a dedicated disk no matter what. We don't want any other volume to be coming from the same disk. So with that in picture, so if you have say 1 terabyte volume and your CDN application is asking for 500 GB of data. So even if you have 500 GB available on that disk, you should not allocate to somebody else, because they want guaranteed IOPS, which is given by the underlying media. So your storage stack should be capable of providing those kind of volumes. The other case is about storage compute affinity. So say your pod is running on node 1 and your EBS disk is attached to node 2. So whenever you do any IO, it will go to node 1 where the pod 1 is running. Pod 1 will needs to talk to node 2 and then access the storage. So that is not performant. So what your application wants is, wherever the pod is running, the storage should be attached to the same node, or it should be allocated from the disk attached to the same node. So application should be able to specify these kind of constraints while requesting for storage. Then it should provide encryption for security and replication for high availability. And this replication, you should be able to say, I want say AZ level fault domain. So essentially, I want 1 copy in AZ1, 1 copy in AZ2, and 1 copy in availability zone 3. So your storage stack should be flexible enough to give those kind of capabilities. And it should be platform agnostic. Essentially, as we said, as we saw from the results, there is more than 50% of the responders are already using hybrid clouds or multi-clouds in their environment. So it becomes very important enough that the stack that works on one environment should work exactly same on the other environment. And since it should be API driven and self-managed so that it works well with the ecosystem that is around it. So that essentially means that it should be CSI compliant so that it works with the persistent volume claims, and it should have integration with, say, Prometheus, so that all your storage metrics, the performance metrics are pushed to the Prometheus so that there can be a actionable input taken by DevOps team. And it should be agile. So it should handle addition of new nodes, removal of nodes, addition of new storage, removal of storage, and so on. It should also be able to handle whether the disk is locally attached. So say you go on premises and the disks are attached to your host. So it should be able to handle that, as well as it should be able to handle the remote disk. So if the storage is coming from SAN, or in the cloud, it's coming from the cloud disk like EBS or GCP disk and so on. So those are the characteristics that you need from a production-ready CNS stack. So with that, let me introduce you to Robin Cloud Native Storage. So whatever characteristics we talked about, that all of them are available as part of Robin Cloud Native Storage offering. It works on any infrastructure, be it bare metal, VM, or any cloud, any Kubernetes, whether it's a KTS, OpenShift, Anthos, or other Kubernetes flavors. And you can deploy any kind of app, considering that app would have a differing set of requirements. It should be able to handle all of those. And since we have experience with deploying big data apps and other messaging services, we know what application really needs. So we have specified all those tunables in our storage stack. So you can see the sample set of customers and the deployments that we have. And some of the analyst mentions are here. So let me move on. So what when we looked at, what we realized is just when you are talking about application deployed in Kubernetes, it's just not the storage that we should care about. It should be the whole application. So it should be a config map, it should be secret, it should be a persistent volume claims or pods and shipment services. So you can think of it as an analogy. So if you are worked in VMware environment, say I want to move a VM from one data center to say another data center for my DR purposes. So what will I do? I will get the VMDK file and copy it into other data store. But is that enough for bringing the VM? No. What you need is you also need a VMX file, which is a config file where there is a mention of how much CPU, how much memory, how much network is this VM need. So you need to copy this VMX file into other nodes. You have to customize it because it will have the data store name, which is specific to this. So you need to customize it, and then only you can bring that VM on the other side. So you can correlate it to the Kubernetes stateful application. So just copying the PVC data is not enough. What you need is also the configuration that is associated with that application. You need what are the pod requirements, what is the CPU memory, all the or the config maps, right? Secrets, wherever the configuration is stored. So that's why when we talk about application, we talk about this. And then Robin allows you to register this as an application. So it can be as simple as Robin app register, application name, you give a health chart name or an operator name, or you can even set selector. So from that point on, Robin will start tracking all the objects which are part of these applications, right? And this does not need to be a single Helm chart or a single operator. It can be a combination of all this. So I can say, I have a front end and back end. I want to group them as a single application. So I can say -Helm MySQL and -Helm my Nginx, right? So that way, Robin will manage data, metadata, as well as the configuration for an application. Robin provides application consistent snapshot. So what are the use cases for these snapshots? So it should be able to, so when user makes an error, so say you delete a table from your database, you should be able to recover from that problem. Or you are trying to do upgrade, but your upgrade fails in meantime. So now you need to go back to your working copy. Or for compliance or security reasons, you might need point-in-time versions for the app. So What Robin provides, just a single command to take a snapshot. So here you are talking about Robin snapshot, this application and a snapshot. So here we will capture application data as well as the metadata and the configuration together. So when you are rolling back it as a package. Now, why do you need to roll back as a single package? What if you don't take this config map or secret as part of your snapshot? So consider a MySQL database which is deployed and the password is stored in a secret, right? You take a snapshot at say time t1. Now somebody changes the password. So the secret is updated at time t2. Now, if you roll back to a copy at t1, and if you don't roll back the secret contents where the password is stored, then what is going to happen is you have a stale password, or you have a newer password, but the stale database. So your database won't recognize the password that you have. So it is very important that you make a copy of the whole configuration along with your data. And it is very fast because we use redirect on write. So it's essentially a metadata operation when Robin takes a snapshot, and it's a very space efficient. It will only capture the changes that have been done after the snapshot is taken. And similarly, now these snapshots can be used for multiple purposes, and one of the purposes is application consistent backups. Now, what are these backups can be used for? It can be used for recover from disk and server failure. So if your data is lost, if your disk goes bad or your server doesn't boot up, right, where your data is stored, you can always bring back the copy that was stored offsite. You will have your compliance requirement where you need disaster recovery requirements where the data should be stored offsite in case disaster happens. Or it might be compliance that some of the customers that we work with have a requirement that they have to switch their data centers every 6 months. So your application should be up in one data center for 6 months, and application should be up in other data center for 6 months. So you need the backups for that. And this essentially is moving the snapshot that we have taken earlier to a remote site. So all the advantages that we have with snapshot will be there with backup. It is incremental. And on top of that, we have RBAC for these backups. So it's secure. Not everybody can use it without access. So let's move on. And we have clones. So essentially, the clones are a copy of the application. So you have MySQL running in production. I want to run some test on that production database, but I can't give you access to my production database. One is due to performance reasons, maybe for security reasons, right? So what we provide is a clone functionality where you can just point to that. You can take a snapshot of your production application, point to that snapshot, and you can create another copy of the application with exactly same data and the configuration. Then you can run your tests, you can run your performance reports, and so on without impacting your production database. And this is a thin clone. So essentially, it will both the applications will share common data, and the changes would be after that. Whatever changes you make will be in their local copies. And this becomes very important when the upgrades are complex, where what you will do is you will not update the original application, but what you will do is you will create a clone of the application. You will upgrade that. If you are satisfied with that, you will go back and upgrade your original application. So those are the advantages of clone. Going forward, now we also support multi-cluster, multi-cloud portability for the applications. So why is it needed? As again, that people are moving to a model where they are using multiple clouds or on-premises along with the cloud. So for those use cases, essentially your application can reside anywhere. It can be in on-premises, and for example, you don't have enough space in your on-premises. So what you will do is you will move this application to the cloud. So there should be a straightforward workflow to move this to another cluster in the cloud. Or there could be another use case where you have applications running in the cloud, but due to cost concerns, what you want to do is you want to bring it onto on-premises. So in both the cases, you need a simple way to essentially migrate apps across on-premises or clouds based on your needs. So here, Robin, what it allows you to do, you anyways take a snapshot, you move to any S3 compatible, S3 API compatible object store. So it can be GCS, Azure, or Minayo. And after that, if the clusters in the cloud have access to this object store, you can just say, Robin pulls this, and it will create the application exactly similar with the data that was there in your cloud, be it OpenShift or IKS, it doesn't matter. So essentially what we have done here is we have taken a backup of the application and moved it into the cloud. So that way you can just move the application as per your will, based on your needs. Now all these snapshot and backups can be taken in a scheduled manner as well. You can set up a schedule for them that I want to take, say, every week, every day I want to take a snapshot, or every week I want to take a backup, and so on. So with that, let's look at the demo of these workflows in practice using Robin Cloud Native Storage. Over to you, Madhura.
Hello, thank you, Tushar. I'm Madhura Gavnikar, Principal Engineer at Robin.io. In today's demo, I'm going to show you how we can use Robin storage for Helm apps and thereon use Robin's data management capabilities. So in a stepwise, what I'll show you is I'll deploy Postgres Helm chart, then snapshot that database, create a clone out of that Postgres DB, back it up that particular snapshot from step 2 onto the cloud, and then port the DB to altogether a different cloud. So before we begin, let's see how we can install Robin. This is a container platform from Red Hat OpenShift, and I have logged into the console of it. So click on Operator Hub and type in Robin. We'll see here two Robin operators, one from Marketplace and one from Certified Registry. Based on your preference, click on the operator, and from there it will take you towards the Red Hat Marketplace. Here you can see there are different pricing options available. You can pick any as per your requirement. So further to that, once you have an operator installed, what we'll do is create a Robin cluster. So let's go and create a Robin cluster. Here you can see there are different options that you can select from. Like Kubernetes provider, by default is OpenShift. We can pick up according to a cluster. I have AWS cluster, so I will pick up EC2. Then let's take a YAML. So whatever options we have selected from form view are reflected here. Now Robin also supports other attributes that you can use. To avail Robin's disk management capabilities, you need to provide AWS secret and AWS access key. So what we ask you to do is create a KTS secret and add it here under options like this. So AWS secret is basically the name of this that holds my secret key and access key, and I have added it to cloud credential secret. Robin will use this and to query the APIs from AWS. Simply go ahead and say create, and this will create an OpenShift Robin cluster. So this is my OpenShift AWS cluster.
I think we lost the audio altogether.
I have 3 worker nodes and 3 master nodes. Using the node selector, I've installed Robin on some of the nodes. Let's see here. Get Robin clusters. Will show you that Robin is installed. So Robin.io is the namespace in which I have installed this cluster. Let's look at the storage class that are being present. So here we see there are 2 storage classes. One is GP2, which is the default storage class of AWS. It creates EBS volumes. And as we have installed Robin, we have another Robin storage class. So what this storage class is, very basic storage class, which creates a PVC with no replication factor or so. But if you want to make use of advanced capabilities, Robin also provides that. So simply, if you get into any of the Robin pod and go inside of Robin current examples, you'll see we have listed here some of the YAMLs and storage class examples. So let's get one of it. So in Robin, what you can do is you can set replication factor, compression, block size, all domains. So when I say replication factor, it can be set to 2 or 3, and depending on that, Robin storage will be 2-way replicated or 3-way replicated. Similarly, for domain, you can say disk, host, or rack, and according to that, you will have replications set across different disks or hosts or rack. We also support CHA-20, AS256, and AS128 encryption. And for compression, we have LZ4. So let's go ahead and begin the demo. And let's create a PostgreSQL chart. So for this demo, I'll be using IBM repository Helm chart. So let's see here whether I've added. Yes, I have added IBM community repository. So these are some of the options that I've set while creating a Helm chart. For my convenience, I've set some password for the PostgreSQL. And very important point to note here is the storage class. I have used Robin storage class. If you don't use this, then you won't be able to avail the data management capabilities provided by Robin. So let's go and see whether our Helm chart is up. Yes, kubectl get PVC, and we'll see that a data movies PostgreSQL 0 PVC is being created using the storage class Robin. Let's see what has happened to the pod. Okay, so PostgreSQL pod is up and running. For the next thing, let's go and create a database into the cluster. So for that, what we need to do is exec into the pod. So we are inside the PostgreSQL pod now. Let's go and connect to PSQL. We had set the password for the convenience. Let's create a database called as crestdb. Let's connect to that DB. And let me create a table, very small table. Name of the table is movies. Let me insert some records into that table. So I've inserted close to 9 records on the table. These are just a sample database records these are sample movies that I've taken from IMDb with different genres like drama, comedy. So we have altogether 9 records in our cluster. So let's go ahead and see what has happened to this chart from Robin's side. We'll do Robin app list, and you will see that the Helm chart that was created using Robin storage class is being auto-discovered and added to Robin database. So from here on, you'll be able to use the advanced capabilities of Robin. Let's start by creating a snapshot. We're creating a snapshot of the app movies, and I'm just giving it a name as Snap Movies for our convenience, just so that we know there are altogether 9 records in our database. So snapshot here is basically a point-in-time checkpoint of your app. It captures metadata, configurations that are part of your Helm chart. So what do I mean by this, right? It will make sure to capture PVCs, your config maps, your secrets, labels, pods, stateful sets, services, so on and so forth. So our snapshot creation has completed. Let's see. Okay, so here is our snapshot ID. So just to create some excitement, let's go and delete a record from our database. So altogether we have 9. Let's go ahead and delete this June 9. And now we see there are altogether 8 records in our database. So what do we do at this point? We have 9 records and we just lost 1 record. Worry not, we can go back to this checkpoint where we had altogether 9 records. So for that, what we can do is, all we have to do is Robin app restore, name of the app, and provide the snapshot ID. That's it. So what will happen is we will be able to go back to the older time wherein we had 9 records. So remember, when we are saying we are taking a snapshot of an app, currently in our example, we had just one PVC. If in case our app had multiple PVCs, our snapshot would have taken care of all those 3 PVCs. You do not have to individually go and take snapshot of each PVC that is part of your app. But at Robin, we take a holistic view of entire app. So all your PVCs will get snapshotted. So also in terms of restore here, when we are saying restore, it will also restore all the PVCs that if you had in your cluster. So what happens during this time when we are restoring an app is that it will delete the pod and create a pod with the same PVC that we had earlier with the checkpoint we had taken with the snapshot. So let's see what is happening now, right? Here, get pod. So what is happening at this point is it has going back in point in time and recreating the pod with the earlier checkpoint. So we can see here that this pod is initializing, pending state, and now it's going into running state. So our restore is almost completed and we have a pod up and running. So we'll see what will happen to our pod, right? Let's go back and see what has happened. So remember, we had taken a checkpoint when we had 9 records and then we deleted one of the record. So now when we go back, we should be able to see all those 9 records. So let's connect first to SQL. And then we had created a DB called as test DB. Let's see how many records are present now. Nice, 9, right? So we have been able to successfully go back to earlier checkpoint. Let's go further and see some other capabilities that Robin supports, right? So let me clear the screen. We will now next move to another capability that Robin supports. Those are called as Robin app clones. So let's create a clone from our snapshot. So we'll say Robin app create from snapshot. Name of my app would be movies clone. And my snapshot ID that is required to create a clone. So when I say I'm creating a clone, what am I actually doing is I'm replicating my application. So consider an environment in which you have production and test dev. You can create a clone of your production app by clone, I mean a replica of your app. And now suppose you have to run some database reports. You can run it on that dev application without affecting the performance of your production app. Say suppose you have to make some data validations, or you have some patch that you need to apply. So all you have to do is take a snapshot, create a clone out of it, apply the patch on that snapshot, patch on that clone, see if everything works. And yes, if it works, you can very well apply that patch on your production environment. So when we say clone here, it is also creating a thin clone, which means we have, which cloning is faster and does not require massive copies of data from one app to the another. So let's see, what will happen here is that it will create a separate set of PVC for the clone. And let's see whether pod is getting created for the clone app. Yes, you see there is a clone app and there is a parent app. So let's get inside this clone app now. So now we are inside the clone app, and we know that we had added 9 records in our parent app. So now we should be able to see those all records in our cloned app. Let's connect to the database that we had created in our parent app, which was called as testdb. And let's see how many records are in that table. Nice, 9 records. So this is my parent app where we had 9 records. I cloned an application, and now I have 9 records in my cloned application. Nice, isn't it? So what all other capabilities does a snapshot provide, right? Now let's move on further and create a backup of our clone. So to create a backup, what we first require is a repository. I have already added a repository in my Robin. So what do I mean by repository? Is like we need an object store, maybe S3 or GCP's GCS, Azure Blob Storage. So what we say is we add that blob store into Robin. So we create a repo out of it and provide the path to that repo. So for my use, I say S3 is my bucket and the path to that bucket. And we need to give certain permissions. We have to create a JSON file with access key and secret key and provide it while creating a repo. Next, what we have to do is attach a repo to our app. So if you remember, name of my app was movies. So what now I have to do is attach my app to the repo. So what actually I'm telling is use my PGSQL backup repo to store the segments of data for my app movies. Next, let's create a backup. For backup, we need is a snapshot ID. So let's do Robin snapshot list. Let's grab the snapshot ID from here, and then let's create a backup by providing the snapshot ID. Okay. So what is happening now is consider a multi-cloud portability for your applications. May it be on-prem, may it be AWS or GCP. In our example, I have shown AWS, and so what we'll currently do is we have a snapshot that was created, and currently we are pushing that data into this cloud storage bucket. So our backup is created. So let's do Robin backup list. Okay, nice. Now what do we do with this backup? For the purpose of this demo, I have created another cluster on GCP. Let me show you that cluster. So I have a GCP cluster. Again, I have 3 masters and 3 workers. Also, I have installed Robin on this. Let's do Robin host list. Another important point to mention here is that Robin has its own control plane. So it makes sure that your applications are available all the time. So let's do and see what we have with respect to storage class. So we have two storage classes. GCP comes with its standard default storage class called as GCPD. And then we have installed Robin. So we have another Robin storage class. So for backup to be imported on our new cluster, we have to make sure that we have added Robin repository. So we have added S3 repository. The same repository that we had added on our source cluster on AWS, I have to make sure I add the same repository, that is S3, with the same path. Let's go back to our source cluster and import a token. Let's create a token, Robin backup export, and the backup ID. So why do we need to export token, right? This is to make sure that your data is secure in the cloud. So this is the token. We copy the token, and then on our target cluster, that is in this case our GCP cluster, I'm going to import that. Okay, so this is what all I did is I took the token and I used that token here to import the backup. Now let's see what is happening. Okay, our backup is imported in the state. You can see the state here. So we can use this backup ID to create an app. So let's do that and create an app. Robin app create from backup. Name of my app is going to be movies backup. I'll provide the backup ID and say, so remember what will happen here is that we are going to import entire application that we had created on our source cluster onto our target cluster. So if you remember from this, I had shown, we had created a snapshot. Then we pushed our data onto the S3 bucket. And now we pull the data on our GCP cloud. So with this backup, we can port apps across multiple cloud environments. This allows you to avoid infrastructure lock-ins and achieve better cost economics. So while this app is getting created from backup, what it happens is it will create PVCs. Let's see. Okay, so it has created a data movies backup movies PVC. Also, along with this, it will create pods. See here. So when it creates pod, it will pull the data from the S3. Before that, while creating container, it will pull images from docker.io, and then spin up a pod, attach the pod to this PVC. Okay, nice. Our app is up and running. Now what we'll do is we'll connect to this pod and see whether data that we had added on our source cluster is available on our target cluster. Let's exec into pod. After this, as we have seen earlier, what we'll have to do is connect to our DB. So if you remember, we had created a test DB on our source cluster. So we have to make sure that we can access that database here. Oh yes. So our database exists. Now let's see if our table exists and all the records that we had inserted. Awesome. So now we see we have all the 9 records that were there on our parent app available on our target cluster. Amazing, isn't it? So what we all did was we created a global repository from which is accessible across all clouds. And a user can recreate the exact same application along with data as well as configuration by importing that application level snapshot or backups onto a target cluster using a single command. Robin automatically takes care of mapping configs data from source cluster to destination cluster. Pretty amazing, isn't it? This is pretty much I had today for this demo. Thank you very much. Over to you, Tushar.
Okay, thanks, Madhura, for the wonderful demo. So I will just have a concluding slide, which I think we talked about what are the features are required. So Robin provides all those guarantees regarding persistency, availability, recovery, performance, and so on. And it can be deployed across any Kubernetes cluster on any OpenShift, whether it's running on AWS, GCP, or on-premises, or any other Kubernetes flavor. So with that, you can use it. You can deploy it from the Red Hat Marketplace on any of your existing OpenShift clusters, or you can download for other Kubernetes flavors. You can download from get.robin.io. Documentation would be at docs.robin.io, and in case you have any questions or need for support, you can always ping us on slack.robin.io. With that, I will open it for any questions that you may have.
All right, great. We do have some time for questions. So if you do have a question for either Tushar or Madhura, please go ahead and use your GoToWebinar control panel and submit your questions. Let's go ahead and dive right into the ones we've gotten so far. Let's see. First question here. I don't know if I can get to, there we go. Okay, CSI itself provides snapshot capability. Does Robin support that? And what advantage does Robin have over that?
Let me take that question. So CSI gives you the PVC-based snapshot, but your application might have more than one. So what you need is a snapshot which comprises of multiple PVCs, which essentially you can call it as a consistent volume group, which should have a set of PVCs, and we should be able to take the snapshot. And as we talked throughout this demo, that just taking the PVC snapshot is not enough for your app to come up. And so you need the whole config map secret and all that snapshot as part of the picture. So, after saying that we also support PVC-based snapshot, and user should be able to take the PVC snapshot as they do for other CSIs.
All right, great. Okay, next question here. Let's see. How much additional space does Robin's snapshots take? Can they be scheduled?
I can take that. So Robin takes additional 40% of your volume size, but this is a default parameter. However, there is a configurable parameter you can use and set the percentage accordingly. With respect to snapshot schedule, there was an add-on question. I see that with respect to snapshot schedules, we do support it. In Robin, there is an app-level command called as Robin app snapshot schedule, which takes app name and a JSON file wherein you can say at what frequency you would like to have your snapshots taken. Also, you can specify retention policy saying that, oh, please retain last 3 snapshots or last 4 snapshots. So yes, we do support snapshot scheduling.
All right, great. I think we have time for one or two more questions here. How does Robin provision disks in the cloud?
I can take that one too. So for Robin, what we do is at the time of Robin CR, we ask user if they want to provide X3 secret key for AWS, or if suppose they're using it on Azure, they have to provide a tenant ID, app ID, and subscription ID. And using this, like, you don't have to give it in a plain text, but you can create a secret and provide that secret to the Robin CR. And using that, Robin will call cloud APIs and can provision this and then add them to Robin storage. However, if you already have this attached to your cluster, Robin will auto detect those and add it to the Robin cluster.
Excellent, excellent. Okay, here's another one for you. What sort of monitoring and reporting capabilities does Robin provide?
Okay, let me take that question. So Robin has a tool called Sherlock, which essentially gives you app to spindle ratio and all the performance characteristics, and also all the metrics related to persistent volumes regarding the storage stack, the IO latencies, and so on, are exported to Prometheus. So it essentially is exposing the Prometheus endpoint, which can be scraped by Prometheus to get those metrics. And we have Grafana dashboards where you can view these statistics per volume or per application and so on.
Okay. All right. I think we have time for one more question here. Is there an API we can use to integrate with third-party APM type tools?
So I'm not sure what kind of integration, but as I said, that we export all these metrics via Prometheus. So if the APM tool can call the endpoint directly, it should be able to get all those metrics, and we have enough labels put in each of these metrics to identify a pod or a application, and you can group them together.
All right, great. Well, we are about 3 minutes to the top of the hour, so unfortunately that is all the time that we have for question and answer period. But we did actually get a lot of questions in, and so if we didn't get to your question, I apologize, but please know that the folks at Robin and Red Hat Marketplace will be getting a copy of all of the questions that came in, and I'm sure somebody from their organization will be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can go look for it there as well. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, I did mention at the top of the hour that we would be doing a drawing for 4 $100 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Alex S. Congratulations, Alex. Second winner today is Ray A. Congratulations, Ray. Third winner today is Luca M. Congratulations, Luca. And our final winner today is Bill G. Congratulations, Bill. We'll be following up with all 4 of you via email to get your Amazon gift card emailed over to you. So check your inbox. If you don't see anything in your inbox, please check your spam folder. All right, Tushar and Madhura, thank you both for a great presentation today. Really, really good stuff. Really appreciate your time and your expertise. And I also want to thank a lot. Oh, you're welcome. You're welcome. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.